Hey everybody, good morning. How you folks doing today? Hey Rochelle. Yeah, I saw that. I said it'd be a series, I think. Was it a movie or a series for Halo? That's it's interesting. They're gonna try and adapt that world, but it should be fun. All right. So we're going to move on to Lambda expressions today from chapter 22 here. And not going super crazy with these. There's a lot to them. We want to introduce them, look at kind of how they work, and get you familiar with them. So we use them a lot actually in our graphical user interface programming if we're doing code for our JavaFX stuff. So far we've been doing all of our JavaFX stuff with Scene Builder. Now you don't actually have to use Scene Builder. And sometimes you want a little bit of the flexibility of not having something pre-built. You want to be able to build it dynamically and say, hey, maybe I only need 3 buttons, or maybe I need 7 buttons, or maybe I need 3 different boxes, and whatever we need to do. If we want it to be dynamic, we can actually generate the JavaFX components in code. And that's what the book has in their chapter, actually. They have us go through that. I'm a big fan of Scene Builder because I think that makes life easier for us. So I always like to use Scene Builder. Let's see. So let me fire up a new project here. Maybe we'll get there. Maybe. There we go. All right, so I'm going to do a Javafx project, but we're not going to use all of the components that it builds for us here. So we're going to look at how we can do this a little bit differently. And this will be our Lambdas. My goodness, I can never remember how to spell these. Yeah. Lambda. Okay, yeah. Just like it sounds, it just looks really funny for some reason. Ooh, excuse me. So we don't actually need all the Fxml stuff here now if we're going to do our JavaFX by hand. So Fxml allows us to define what all that looks like here in a separate file. But we don't need to use any of those. So I'm actually, oh, you know what, let's, yeah. I think this will be fine. All right. So I'm actually going to get rid of a lot of this stuff here, and that'll be okay. We'll just kind of pare it down. So we can do, oh my goodness. There we go. I'm going to delete this one. Oh, it's working on the files. All right, yep, and let's get rid of that line. It's smart enough when I was deleting. Sorry, I was telling me I was using it. So then delete again. Try that. Hey Shady, how you doing? So we're going to look at how we can do JavaFX without Fxml here, and then some of the Lambda expressions will make a little bit more sense and what we're going to use them for here. All right, so we need, we would say an anchor pane equals a new anchor pane. Yep, add our import. There we go. Does it need anything here in the constructor? I don't think it did. Okay, cool. Nope, that didn't copy. That's fine. So we can set the scene with an object we create. So we can make instances of these classes here right in code, which is pretty fun. And then start setting these things. And then in our pane, we can go and add other items here. And then again, this gets a little tedious to do in code, but it does have some advantages for sure. Right? So if we have a very static display, Scene Builder is great. And it's a great, easy way to get started. So we don't have to do all this stuff with code. But if we want, once we're using code, everything can be nice and dynamic, which is really cool. And so I could say, hey, user, how many people are playing this game? And they say that it's 3 people want to play, and we'll make 3 different sections here. So I can say, hey, I want a label equals a new label. And then I can take my, come on. Can I just do Javafx? No. Import, please. Scene.control. Okay. Take our pane, and now we need to get the children. Here we're going to get the children, and then we're going to add a node to it, and we're going to add the label. So label, eventually, somewhere in the hierarchy is a node, right? This add said, hey, you have to add a node. So if we look at the Javafx label class, I think we can see it in here. So Javafx scene node here, and then there's a parent, there's a region, there's a control, it's labeled, and then we have the label itself. So way up there in this hierarchy is a node. So anything that is a node, right, we can add to this pane here, right? The children is just a bunch of nodes. Okay, and then we can take our label and we can set the text to say hello world. Okay, now do we tell it? Let me just add. Let's see what we get here. Let's see if this one runs. See if we can't get our little hello world with some code. So far we don't have any lambdas yet. We're just trying to set the stage. There we go. And now we get hello world. All right, really awesome program here, but again, we're working on it. Okay, so usually you don't want to add them directly here, right? It kind of put it in a funny spot. So what we would probably want to do is add some sort of grouping here. So I'm going to make a VBox to group these things together. VBox equals a new VBox. Okay, and then we'll actually add the VBox to the pane, and then my VBox dot. We can get the children here, and we can add the label to the VBox. Because as you add things to a VBox, right, they'll just start stacking themselves for you vertically, which is really nice. So we can add more things here. So the next thing we want to add is a button. So button equals a new button. This will have a button. And then we can set the text of the button and say click me. And then we'll take the VBox, get the children, and we'll add the button. Okay. Now the button doesn't do anything yet though, right? But we want to see if it'll show up. So the VBox is just kind of a way to group them, and it will automatically flow, right, stack them vertically, which is really nice. Trying to put things when we're doing by code in pixel order is a little bit tricky. It's not it's not impossible. Unpossible. That's not a word. It needs more coffee. One of these layouts is a little bit easier to handle if we're doing it this way. Oh, didn't I hit run? It's okay. It is thinking about it. There we go. Now we have the hello world, and we get the click me. And it doesn't do anything yet. So now what we'd have to do here, once we have buttons, right? Now we're almost to where we're going to do lambdas here. Buttons need to do something, right? And how do we tell buttons what to do? So we need to set is it the event dispatcher? I think that's what it is. You know, sometimes you got to pull out the book and double check here. Make sure we're doing this the right way. Let's see. Nope. Okay, so it's set on action. Here we go. So set on action. So needs an event handler that takes an action event to do something. So a couple options for this here. A couple options. The slowest and most tedious one here, but it's doable. It's okay. We can make a new class here that has a method for event handler. Okay, so these are called inner classes. We'll have a class. This is my button handler. So we're going to put a class inside of a class. Now, this is generally bad form here, but what this means is this will be a private class here. You can only have one public class per file. This is the public class hello application in the hello application Java file. So I can put a private class here, and inside of that I can have a method for this event handler here. So we want to say add override, and we want it to be an event handler with void handle an action event. We'll call event. So to do, let's see, I'll add our import here. To override, right, this needs to go and, which one is it? It needs to implement event handler of type action event, I think. Implements event handler, set it, import the class. There we go. So there's an interface here for event handler of type action event. Now this type stuff is not going to make a lot of sense to get to the data structures. Don't worry too much about it, but essentially like when we did array lists, we set array list of a given type. This is an event handler of a given type. So we're saying specifically it will do this action event here and handle those. And then when we handle, right, what are we going to do here? Now the reason why we want this to be a private inner class is so that it will have access to other things inside of our class. So right now this label only exists inside the start method. Right? This is the only place we have access to it. So we can say, hey, I want a private label here at the class level and have a class level variable for it. And I can instantiate it here in start But then what I get to do here is in this part of the code, I can say label dot, because it's a class level variable here. So I have access to it in other methods of my class. So this is a private inner class, so it also has access to our private variables here. It's part of the class. It also has access to the class level variables. So it can set the text to, you clicked the button. Here, so this is writing a private class here to handle these events. So then when we say set on action, what do? We say we're going to set it to a new button handler. We say, okay, here's the instance of the class here. You get a new instance of the button handler class for handling your buttons. Okay, let's give that a run. So when there's an action, it will use this class here that implements this interface and call the handle method. Now we click it. We click the button. All right, it's working. This is good. This is good. Our example is working. We're in for a good morning. Now this is the probably the slowest way here. And we say, well, this is a lot of typing for us to do, right? And wouldn't it be nice if we could do it faster? So I'm going to actually make this button be, this we'll say slow, or I don't know, private inner class. Now, just one fun thing to note here. Let's see, we should see it, this classes folder here. Is that where it gets built? I think it gets built there. Open in Explorer. Let's see if we can find it in here. There. So there's the hello application.class, right? When we compile our Java code, we get class files. There's also a hello application $ button handler. Button handler was the private inner class of hello application. So it generates its own class code, which is kind of neat here how it does that, right? So this is a private inner class, and you can actually see it in the compiled code, which is just kind of fun. So it knows that there's another class that it needs to compile here, which is kind of cool. I think it's kind of cool. All right, so the other thing we can do then is we can make a button equals a new button, and then this one is my, nope. How about another button equals a new button, and then another button, set text to click me. This is the anonymous inner class. So with an anonymous inner class here, what we do is when we set the button handler, here, let me move this one up with the other button, sorry. We'll say another button dot set on action. And in set on action, we say, hey, I want a new event handler of type action event here. And inside of that, at override, the public void handle action event label.set text to let's see, anonymous. We'll just turn the text to anonymous inner class handler here. So without defining a class itself here, we say, hey, I want to have a new instance of a class that is implementing the event handler action event interface. And it's telling us, hey, we can replace it with a Lambda. It's these are common enough to happen all the time here. And I think we can even really get rid of that. No. Okay, it doesn't let us. So this is the event handler being written essentially inline here. So there's no name of this class here. Now the downside is I can't reuse this one ever. Where with the button handler, if I had 5 different buttons, I could set the onAction to the same class here 5 different times. Remember, one of the things we can look at is where the event source is coming from, and there's all sorts of cool things we can do with event handlers to see, what click the button, and we've got options here. So if you're reusing it a lot, it's nice to actually have that private inner class. If each button gets its own, then there's no need to reuse them here. Hector, my friend, thank you so much for donating those bits to the Student Scholarship Fund over at the University of Michigan Dearborn College of Engineering and Computer Science. You're a legend, my friend. Thanks for coming along with us. Can I tell you guys about their Giving Blue Day? Their website crashed, which was kind of sad. I guess it was a good thing. They got so many donations it crashed the website, but just sad. All right, so let's give this one a try. So this is with an anonymous inner class. And I want to open this one back up again too. Let's do Open in Explorer. Well, this one runs. That's not what I wanted. No. Open that window in Explorer. Come on, friend. Open the whole window for me. We still haven't done a Lambda yet. We're getting there. Promise, we're setting the stage for Lambdas. Oops. So I made the button. I never added the button anywhere, so we can't click it yet, right? We need to add it to our VBox. Let me try and put all these in the right spot here. Just trying to kind of order these a little bit better here, right? Make the anchor pane, make the label, do the VBox thing. Okay, so we'll add it to the VBox. So now we need to add this button, the another button, to the VBox as well. We can click it. Otherwise, it's not going to show up. So where do we want to do all those? Let's set all these over here. Okay, we're getting there. Just trying to clean it up a little bit here. Now we should be able to click both buttons. I want to see, did I get some code in here? And now we see an anonymous inner class. There's no name here, so it's just $1. 1 being the first anonymous inner class that it finds. So it still gets compiled to its own Java bytecode, which is kind of cool. Right, so you're still getting these bytecode generations here, these class files getting compiled. All right, now let's see if we can actually click the button. Maybe. Maybe. All right, there we go. So private inner class, you click the button, anonymous class, anonymous inner class handler here, and flip between the two, and they do the thing. Now these ones are fun. We can debug them, which is nice, right? I can put breakpoints in at any point in here, either in the anonymous inner class or our actual defined class here. Oops, not that. I need that line here. Notice that was like a diamond because that's the method definition. This is the actual, there's code here that's going to run. So we can run this in debug mode, and we can watch it in debug mode. It's good. I had to upgrade to the big mug today instead of the usual ones. Yes, let's allow access. Thank you. I think I clicked allow access. Come on. All right, and with the private inner class, here we go. So this is where we are currently. So this current instance, right, is the button handler. The event that was passed, right? We know the target here was the button. The source was the button. which is cool. So this source field, you can actually like see cool stuff about the buttons. And then we have access to the label here. Again, all sorts of weird properties that we probably don't really care much about. Debugging with FX is weird sometimes because there's just so much other stuff around, but we could actually run in the debug mode. Right, and I'll just continue here. We see that one, and then we have the anonymous inner class. It will also debug as well, right? It'll pause here for us. This is our application, right? We still get the event here where you can see the label, right? So we're not seeing, though, these other attributes because we're not technically inside of the start method. The start method is already run here, so I don't see any of these other values here. So I only see the class level attributes. Right? It looks like we're kind of inside a start, but this is just where the code is. It doesn't actually, the start method is not running. Okay. Now we can do it with a Lambda. Okay. So let's make a button. This is a Lambda button with, I don't know, Lambda. Equals a new button. Button.setText. Click me, I run a Lambda. Okay, and now for our set on action, we say button.setOnAction, set on action. What do we want? Well, we want there to be an event here, and then we use this arrow notation. A dash, is that a greater than? Dash greater than, I think, is the arrow notation. And we say, well, what do we want to have happen? What's the method that handles this event? And all of this works because we know that set on action needs something that implements the event handler interface. So we just say, hey, I'm going to call the event here. And you can even call it E. I'm not a fan of E, right? I think it's probably a little easier to spell it out here. So we're going to set on action the event, and what's going to happen when we click the event? Well, I want to take my label, set text to Lambda. So this here is the body of the method here. So it's like an anonymous inner class, but a lot less typing. Because all of this here is essentially implied because we know set on action needs something that does that. Right? So it's able to do that matching and say, oh, okay, I know you need to implement the interface, and I know you need the handle method. So here's the handle method. Right? Everything else, please just assume this is what I want to have happen here. And then we need to add that to the VBox. I'm sorry, button with Lambda here. I was going to set this in the wrong place here. And then my VBox dot get children dot add the button with Lambda. Okay. Let's see if this one will run now for us. Lambda. Now, it's kind of tricky to debug this. It's doable here. I think we can debug it. I think we can put a breakpoint right there. It's just a little bit awkward sometimes. Let me give it a format. Maybe we'll bump that up a line too. I don't know. Let's just see if it runs first. It's thinking hard about it. Let's go Javafx. Lambda. Okay, so they all do the things. Right? They just are written differently in code. All right, let's try it in debug mode. See if we can't get the debugger to stop here. Lambdas don't usually work well with debuggers, which is a little sad. And sometimes the format's real funny. So they're short and concise, and people like that because developers are lazy. Right? We like to type less if we have to. Use the Vim plugin. I can easily format it. Yeah. All right, cool. All right, so it did pause here at the debugger. So sometimes it doesn't like to do that. But it looks like we're stopping here. So cool. That's a good sign. And then we'll just continue on. Now, oh, come on. Oh, it has to rebuild Lambdas here. Now notice there's no generated class code, though, at this point. So the Lambda's not giving us an anonymous inner class. It's not giving us an inner class. It's not even its own class. Right? It's all part of the hello application class itself. So the other ones, right, the anonymous inner class still gives us one, or the full class gives us one here. But it all is going to do the same thing for us. Right? It all accomplishes anything we want to do, any code we want to run inside the set of curly braces for the handle method. What does it want to do with that? Replace with expression lambda. Isn't that what I had? Oh, okay. So the curly braces were technically optional. Okay. Sure. That's fun. So you can skip the curly brace for the method. So if it's, yeah, this will work here. I just like curly braces, I guess. I don't know. I'm a fan of curly braces. It'll all work this way. So you don't need to use the lambdas, but you can. Right? It's definitely an option here. All right. The next super crazy thing that we can do here is kind of fun. So let's go through, and I'm going to kind of follow along the book's example here, because it's a little mind-bending how the stuff works here, and then we're getting definitely into some advanced Java stuff, but it's super powerful if we can wrap our head around it. Okay, so what we want to do here is let's go and make a class here. Okay, so let's come to our package here, and let's make a interface. Oh, I didn't have an easy one. That's fine. There's an interface. Okay, and we want to call this one our. We'll rip the whole thing out. This is testing contact. Why not? So the interface for test contact is going to say, hey, I'm going to have a method that will return a Boolean for test given, and we'll call it a contact. Now we need to go and write that contact class, because I forgot to do that first. We'll write a contact class, and then contact will have some information here. Did we even go through it here? Yeah. So contact will have a private string for name, a private string for email, and a private string for phone. Okay, and then we'll generate the rest of the code for it here with constructors and getters and setters, and we can get a bunch of values out. Getters and setters, sure. And then let's add a constructor that takes all of them. And then we also want to add a no argument constructor here, because we might not necessarily have all this information here. So I'm going to add a no argument constructor with none of them here, right? So remember, the defaults here are null. I always prefer to be explicit, though. Reference types will give us null by default, but if we are going to write the constructor ourselves, it's nice to have one. We could have just used the Java default constructor as well. Right? The default constructor will give you null for all of your reference types if you want. Okay? So now that we've got that, test contact knows what a contact is, and let's put together a list in here. So a private array list of type contacts. Here, let's import that, and then let's fill it up here. So we'll say contacts.add a new contact. Chinesky is my name. Right, what do we have? Name, email, and phone. Char1. So the funny thing here, usually it's first name, middle initial, and then 6 letters of your last name. I previously worked at OCC on the IT side here, and I had the correct email address. And when I came back as a faculty member, they didn't want to reactivate that account because it had all sorts of other permissions assigned to it. So they just made a new account to keep the old one completely separate. And so it makes it look like there's another one of me out there, but no, it's the same me. So I don't know why IT chose to do that, but that's what they did. And then we'll say null, I don't have a phone number for this one here. Okay, and then let's add another contact. Let's add Dr. Baugh, JP Baugh, and let's go look him up real quick. Catalog site. He's listed. I know I can find his info over here. In our software engineering program, we've got a page for it here, and his name is listed down here. Now, this is where I go for whatever reason. Dr. Baugh. Oh, it doesn't even have his email. Oh, there's jpbaugh@opencc.edu. So we'll skip his email address and just put a phone number in, because why not, right? Oh, that was running the whole time. Oops. So we'll skip an email address. We'll say that's a null email address, but we'll give him a phone number. I'm sure he doesn't actually check that phone. That's his office phone. Okay, and then we'll add, who else should we add? Should we add our buddy Ken? We can add our buddy Ken. Contacts.add new contact. Oh, I should just copy paste that whole line, shouldn't I? That'll be easier. We'll add Mr. Ken Ziegler, and he's got an email address in here, right? It's K.E. Ziegler. There we go. K.E. Ziegler at opencc.edu. And we'll put this number. There we go. Nope, this one. All right, cool. Yeah, this phone number, apparently I have one. I never use it. If you call it, the voicemail message says, please don't leave me voicemails. I never check this number. Call my cell phone instead. So I couldn't get them to put my cell number here because whatever reason, sure. All right, so we had a couple contacts here, okay? Then what we want to do here is we want to, let's see, so we can list out our contacts. So we can say, hey, I want a list. Oh, look at that, where our last name is spelled wrong. If you wanted to get a array list of type contact, that is contacts without phones equals new array list of type contact. Again, we're shamelessly copying off the book here because hopefully there's similar crow. Yeah, we can go define them. You have to define them a little bit special here. So we're going to look at defining our own here in a minute. So if I want this list of contacts here, I can say for contact in contacts, right? If the contact.getPhone contact.getPhone is null, my contacts without phones .add the contact. Right, so this is going through, filtering it all out, nice and slow here, right? But eventually we could go and do something with it here, right? Or, you know, we could even take all of this here and pull that out to be a method here. So let me refactor and introduce this as a method, extract method. This is get contacts without phone here, without phone. Okay, and we want to make it static and pass the field for contacts. There we go. I like it. Okay. So you give it the contacts, it will make a new array list, and then when we're done, we can return that contacts without phone array list. Without phones array list. So then the type is not void here. So we've got a little method that we can call to say, hey, I want an array list. This is contacts without phone equals the get contacts without phone given my contacts list here. We have a method that can go and essentially filter these sorts of things here for us and say, okay, that's cool. But now if I want to say, okay, how about the ones without an email address? I've got to do it again with another method. Right? So it just takes a little while here, but you can do it. Not the worst thing in the world. What we can do instead is we can write a method here. So we're going to write a private static array list of type contact. This is, we're going to call it filter contacts. Filter contacts, given an array list, we'll call it contacts, and then something that implements the test contact, we'll call this the condition here. And this is all shamelessly copied from the book, chapter 22. Okay, so if you give me something that implements the test condition, right, which we said the test contact had a Boolean that would return Boolean was true or false given a contact here. So then what we can do, right, I can say I want an array list of type contact. This is the filtered contacts equals a new array list of type contact. Cool. And then I'm going to say for contact in the contacts list if the condition dot test the contact. Right. So the test method here will give me back a true or false. So if it's true, then whatever that condition is, I'm going to add it to my filtered contact list. Add the contact, and we're done. We'll return that. Return my filtered contacts list. So you can specify anything that implements this interface here, right? Anything that implements this interface you can give me here. So then what we can do here is, instead of having to write our own method every single time, like here's my get contacts without phone, if I have one that takes a test condition, right, I can implement it different ways. So I can have an array list of type contact. This is contacts without email, is my filter contacts, given the contacts list. And then I need to give it a lambda. So I'll say contact and then arrow for my lambda notation. And again, the curly braces are optional. I like curly braces, but sure, we don't necessarily need to do it. Contact.getEmail is null. So this here is an anonymous method, essentially. So lambdas are just anonymous methods, anonymous classes here. Implements that interface, because we said, hey, it needs to be something that is a test contact interface implementation. Well, this one implements that interface. It returns, given a contact, it will return a true or false. So this implicitly implements the test contact interface. Implicitly? Okay, cool. There we go. Sometimes I can spell words. So this here implicitly implements an interface because filter contacts knows that it needs that, right? So we could do the same thing here. So this was the first way of doing it. Here, I'm actually going to comment that one out. The other way of doing it then, right? Instead of that method, we can use our lambda. Say contact.getPhone is null, right? And again, this is sure, you know, that we're just doing some basic filtering here. We could also do another one here. Oops, let's do, this will be contacts with 248 area code. And we could get slightly more interesting, right? So your phone is not null, and contact.getPhone.starts with 248. So our filter here is more than one condition, right? But it's ANDed together, so eventually it'll be true or false. It's not null, and it starts with 248. And you can start building any of these things out as you want here without having to add more methods every time. Right, so you can see it's very flexible in that we can define whatever we want to be this test contact test method here in just a quick little Lambda notation. Right? Right, we could do another one here. Let's just for fun, let's keep doing some examples here. This is contacts with OCC email. Our get email is not null, and our get email, how about contains or ends with at oaklandcc.edu. Right? So you have an email address and it ends with oaklandcc.edu. Again, we can make any of these filters that we want here fit, because these will implicitly implement those. So it's kind of crazy. Does that make a little bit of sense? You folks are doing great so far. This is weird stuff here for sure. Definitely weird stuff. Okay. All right, why don't we take a quick break? I gotta go refill my coffee. Make a quick pit stop, and then we'll come back. We'll wrap it up with the last little bit of Lambda expressions, looking at a couple built-in interfaces, which are really cool in Java. We're not going to do the stream part here. I think that's beyond what we want to get into. A little bit more advanced for sure, but it's there if you're interested. We'll look at the functional interfaces in the Java API, which are really fun. All right, so when we take a couple minutes, come back, and then wrap it up, okay? How about some actual volume? There we go. All right, so we're back at, that put us at 11:02. Okay, see you folks in a couple minutes. Howdy friends, welcome on back. Almost caught it in time there. Just between changes there. Alright, so we're going to wrap up Lambda expressions. Again, we're not covering everything in the chapter. Most of it we're getting to. And then we'll be in pretty good shape, okay? So this was fine, but we had to write our own interface, which was a little bit annoying, right? For just something like, hey, I just want a test method. Turns out that is common enough. Go borrow this again, that we don't need to actually write our own. Right? There's a couple built-in classes in Java that will do this for us. So instead of using test contact here, we're going to make a private static array list. Oh my goodness, let me just take most of this here. How about that? This is filter contacts. We'll call this with predicate here, given a predicate of type contact. We'll call the condition. Oops, predicate. So this gets a little long here, but that's okay. Predicate. This is java.util.function predicate built into the Java API. Condition here. And we're going to do the exact same thing here. Now with predicate, though, oops, one more time. There we go. It's condition dot test. Look at that, copy paste, nice. So the test in predicate here, so we look at that predicate interface, Java API predicate. We'll search this one real quick. This is the predicate class. Has a test method here that returns a Boolean. Okay, so given some sort of input, whatever this type T input is, will return false, right, or true, depending on which one it is. The other ones are kind of crazy. Don't worry too much about it. We don't want to get too far advanced here. But this predicate now is a built-in interface. So I can do this same sort of filtering here. This is filter with predicate. How about this is with names starting with E? I don't know, why not? And get name is not null, and get name starts with E. Right, and really just in case here, because I have no idea if this is uppercase or lowercase here, or starts with a lowercase e, right? Either one of those. So that's a predicate. So it looks exactly the same. We're still giving it the test condition here, but we don't need to write our own interface, and that's the huge gain here. So the predicate, don't to write your own interface. So again, only if the one thing you're doing is a test, right? There's not, you can't have all sorts of other interesting features, but if that's the only thing you're doing here, there's a built-in one. So this is common enough as a predicate to say, okay, sure, you're going to give you an object and you tell me yes or no on it. You tell me true or false on it based on whatever you want here. And we are mapping it saying, hey, it's a predicate of type contact. So you have to give me a contact here in the condition. Right? And that's how it knows what that is. So this predicate of type contact, right, we're going to pass it a contact, or we'll call it contact, right, because that's the type that it was here. So you can actually implement the interface if you want here. Like this, we could say implements predicate. Implement. That's fine. It's not even worth typing. But we could say we implement that interface if we wanted, right? Because we'd have our test method here, which is pretty cool. So that's really handy in terms of filtering. There's also a couple other built-in ones here. So that's the predicate one. There is a consumer that gives one here, whether or not it will accept a value. So it doesn't return a value, it does a given task. So if we wanted to write a, let's see, there's our method here. Private static array list of type contact. Actually, so this as a consumer is probably just void here because it's not going to give us anything back. We'll say this is, what do we want to do here? That's fine. We'll just call it process. That's what they do, process contact. Given an array list of type contacts, and given a consumer of type contact, this is our consumer. So consumer will use the contact to do something with it. Import our class. So again, pretty simple list here, loop here. We're just going to say consumer dot accept the contact. So accept is the method that you add in here that does something with it. So we don't even need an if here. We just, on all of them here, we'll just run this accept method. So you give me a contact, you give me the consumer method that will do something with the contact, and we'll do something with it here. So for process, you can do all sorts of different processing if you want here. Right? So we could say, hey, I want to call my process contacts. I'm going to give it the contacts array list, and then I'll give it a lambda, right? Contact. And what do you want to do? Let's, what does this one do? Like uppercase everything. Why not? So we'll set the name to contact.getName .to uppercase. I don't think you need that local root thing. I think that should be fine. So it'll go through, take all the contacts, and then uppercase their name. Set the name to their name uppercased. Why not, right? Anything that we want to do here, right, we can go and run some method on contact. So for every contact, it will go and do this thing here. Again, not all that super interesting because we could just do our own loop, right? If that's all it is, we could run our own loops here. But if we're going to be doing lots of different processing, right, it saves us a little bit of typing. This one's not quite as interesting here. It doesn't give us, save quite as much. But you can get kind of crazy with some of these things here. This one I'm not as big of a fan of because it's quick and easy to just do a loop over the method. Right, we can do our own loops, but you can give it for anything here. It doesn't necessarily have to be a list of contacts, right? We just need to do something with the contact given. That's all. So that one's kind of interesting. You can do a couple things with it, and then there's also the function interface. And functions are fun because it will do something for you. It'll apply the function and return a given type. So I think this is what you're looking for, Crow. More of these sort of Lambda functions. Now these ones get funny here. So let's say, hey, I want public static. Now I'm going to return an array list of type string here for my transform contacts given an array list of type contact, call the contacts, and then given a function here of type contact, and then, so this is the type that it is, and then the type that it's going to return, string here, is the function. So given a contact, you need to give me back a string with this function interface here. Import the class, there we go. So what we want to do for this one here, we want to have an array list of type string, and this will be our strings. It's a new array list of type strings. Excuse me, and then for contact in contacts, the function class here, we're going to take our strings, we're going to add to it function dot apply to the contact. So apply is the method that's defined in the interface. It says if you give me a contact, I'll give you back the type of string. So function, this is type comma type. There's two types here. This is the in type, and that's the out type. So this is type goes in, type comes out. Right? Does that make sense when I say goes in and comes out? Right? The type you're passing and the type you're returning. Passing in, maybe? Passing in, type returned out. So transform is really cool. That you can do a lot of things with it here. And then we'll return our strings array list. So this now, I can give it any sort of, hey, given a contact, give me a string back out, and transform those contacts. So we could get, say, this is an array list of type string here, and this will be my result here. We want to get, what do we want to call this one here? Contact phone numbers. Sure, contact phone numbers, I like that. Equals a transform contact, given the contacts array list, and then our Lambda function. Well, what do we want to do here? So this gets a little bit funky. But what do we want to do, essentially, here is, now I'm going to use the curly braces because we're going to have more than one line here. Let's say the string for phone is contact. They use this ternary expression. I'm not too fond of it here, but that's okay. So we'll say contact.getPhone. Contact.getPhone. Now, if that equals null here, excuse me, then I want an NA string. Otherwise, I want getPhone. I know it looks really crazy here. So this is saying if this is true, do this one. This is the ternary. I think we've covered these, or you might have talked about it in 1500 much. I don't know if those ring a bell. It's just a condensed if else. So if this is true, you get the question mark. If it's false, you get the colon. True, you get the false, you get the colon. This syntax is real funny here, but that's okay. And then we're going to return c.getName, contact.getName. My goodness. They like to use C. I always prefer to spell these out. Plus colon plus phone. Right, so we're going to take the name and the phone number, plug them all in here into a single string, and then I can get back that list of contact phone numbers. So with null, I just get NA, otherwise I get the phone number. This keeps me from getting the ugly nulls here. Right, trying to pass in that. We can go through and we can check all those out, which is kind of fun. All right. So you can use as many of those as you want. You're kind of in a list. So they go through and kind of combine them all together. That's just starting to hurt my head. But it's using some of the built-in ones. We don't have to write our own interface. So you'll see transform is real common because it gives you, or the function is real common because you say, hey, given this type, give me this back out. Now, again, we could have just done our own loop here. Right? There's nothing that says we can't do our own loop that does this here. But then if we need to do other transformations, right, we kind of have a method in place for it. So not necessarily saving us a lot of code here in this example, right? The filter definitely does, right? It gives us, I mean, we could do the loop ourselves. So this saves us a little bit of code here doing different filtering with the predicates. Predicates are pretty fun. But, you know, the processing and transforming or doing our consumer or function depends on what you do, but you'll see these a lot. People really like Lambda expressions. They're becoming more and more common as we go. Okay, so why don't we follow, I don't need that locale. My goodness, that's quite the import list here. Quite the import list. So why don't we for a lab today then? Because we didn't have a lab yesterday, or on Monday, we just talked about the projects. So we'll fire up a new lab here. And give you a new link. So most likely, if we're doing our Javafx programming, right, we'll see lambdas here. with these sort of setting stuff. You will see them other places as well, though. But so if we wanted to do any of this stuff with code, we do it here. Now, we weren't doing that with Javafx because we would have it all defined in the controller. We'd have existing methods that would do these sort of things. Right, and each method then would do the right thing here. So if we look at like our other example, let's see, let's take a look at our Javafx. Look at our controller. So it doesn't add the @override. That's all happening with the Fxml behind the scenes, right? It's just a method here. We don't need to make that private inner class. So it's just a method that handles it. And behind the scenes, Fxml kind of maps it to say, oh, okay, it is essentially a method of the class that implements this interface for event handling. So the Fxml stuff, I think, is really nice and clean. I'm a big fan of Fxml. But all right, so let's get you your link for a new lab. It's gonna be lab 11. Right, lab 11. Oh my goodness, I still gotta grade your thing. I'm so sorry, folks. I will get to these. It's been a rough week. My daughter was in the ER on Tuesday. I lost all of Tuesday. And then Wednesday she's sick. She was still sick last night. It's been a rough semester, friends. It's been a rough semester. I hope yours is going all right. All right. Put this in labs for a text submission. CIS 2151, enter 2022, lab 11. Oakland Community College Java template. There we go. Nope, no tests. There we go. All right. This one here. Submit the feedback pull request URL. So do next week, April 7th. Hooray, we're into April. 10 points out of in the labs category. Oh, cancel. Hang on, I gotta give it a title first. Lab 11. This is Lambdas. Now we should be able to give it, okay, there we go. In labs, it has a nice name now. A basic Javafx application that, so we want to add a couple buttons. Hey, how you doing today? Mustafa, good to see you. That has 3 buttons with a Lambda expression for the set on action method. Go for it. As long as, we're in the middle of class, but if it's on topic, I'll do what I can to answer. All right, so we're going to set that on action method. So for this, now let's see if we can't, let's see if we can make it a little bit more interesting. How about we, method, have the computer, or have the player, okay, so each method, we're setting the label. Setting the label, the buttons should be for rock, paper, and scissors. And scissors, have the computer pick a random choice and display the winner. Test automation engineering. Testing is huge. You're talking about writing unit tests and integration tests and those sorts of things. Yeah, testing is definitely a fantastic thing. Big fan of tests. So display the winner, like excitingly display the winner. So you have the 3 buttons, and then like 1 for rock, 1 for paper, 1 for scissors. That's what the player is. The computer gets a random choice, and then we figure out who wins from there. Okay? That's what we're going to do for the little lab exercise. So a little graphical user interface, rock, paper, scissors. with the Lambda. So this is not with JavaFX. Sorry, I should specify. Without using JavaFX. So kind of doing it this slow way, building out probably a VBox. I mean, any kind of way you want to organize it, it's fine here. So let me specify that. I'm sorry, JavaFX, not Fxml. Not Fxml. Or without. How about without Fxml? Okay, so we'll practice that, and we can go from there. Okay, folks? Any other thoughts, questions, concerns, aside from the grades here that I've not done? I'm sorry. So I want to do your midterms first, because if you submitted your projects, you're supposed to do that self-assessment with the rubric. So hopefully you know how you did on the project. So I'll get your midterms done first for you, because I know that's probably the biggest question mark. And then I'll get to the projects second, okay? Again, sorry for the delay. It's been quite the semester, so I appreciate your patience. Sorry for the trouble there. And we can go from there, okay, folks? That sound like fun? All right, awesome. If you got anything else, let me know. If not, I will see you folks on Tuesday then, where we'll pick up threading. Threading's a lot of fun. There's actually a really cool YouTube video series I just saw someone had shared. There's a lot of things we can do with threading. So we're just kind of scratching the surface of threading. And you can go deeper if you want to. All right, folks, I'll get all this code committed to GitHub. So you've got it for examples. And then we'll call it a day. Let's see if I can get my GitHub to load here. Should we put some more music on? I can throw some more music on real quick while I wrap this up. I'll get that posted for you. Close out IntelliJ. There we go. Come on, GitHub. 51. All right, awesome. All right, folks, I'll see you around. Take care.